For 10,000 years, timber built our civilization. Every residence, every crossing, every sailing ship started out as a tree. But right now, over in China, construction teams are erecting massive 7-story towers and bridges capable of holding heavy trucks, all using a substance that fully regrows in under 10 years. Something that was previously brushed off as just a material for simple huts. Something that was never actually a tree to begin with. It flexes without snapping. It traps carbon inside rather than venting it into the atmosphere. And it is already durable enough to support heavy traffic across rivers. It sounds completely absurd, but it is happening right now, today, in 2026. Keep watching, because by the time this video finishes, you are going to see exactly how a simple plant that experts mocked for over a century transformed into one of the most revolutionary construction materials on Earth. If you are finding this fascinating so far, please tap the like button. It truly helps produce more content just like this. And make sure to subscribe so you do not miss our future videos. Because what we are looking at is not some small-scale university test. We are talking about massive structures, functional highway bridges, and a sweeping national strategy that is shifting how an entire nation builds. And the wildest detail of this entire narrative, the solution was hiding in plain view for nearly 4 decades before the industry finally paid attention. Let us dive in. Timber has been our go-to building resource since the dawn of civilization. It offers incredible strength, natural warmth, and anyone holding a sharp tool can carve it into practically anything. Humans have been felling forests to create shelters for countless generations, way before the concept of structural engineering even had a name. However, conventional wood carries one massive flaw that the industry rarely discusses. It is incredibly slow. A standard tree, sturdy enough for heavy construction, requires anywhere from 25 to 75 years to mature. Pause and consider that timeline. A sapling put in the dirt today might not be harvestable until your future grandkids are fully grown. Our modern society simply cannot afford to wait around like that anymore. Urban centers are expanding at an unprecedented rate, and traditional forestry cannot supply that massive demand. Consequently, builders shifted to concrete and steel instead. Those alternatives are incredibly rapid and amazingly tough, yet they carry a massive environmental cost. Combined, the manufacturing of concrete and steel accounts for upward of 15% of all the carbon dioxide humanity pumps into the air annually. That is the frustrating trap architects have been stuck in for decades. The sustainable option is gentle on the earth, but takes a lifetime to grow. The rapid options can match the pace of modern cities, but are devastating our climate. For the longest time, it seemed like an impossible puzzle with no real answer. You either chose slow and green, or fast and polluting. There was simply no third choice. That is, until one nation decided to re-examine a forgotten plant from a completely fresh perspective. To grasp why it took so long for anyone to notice, we have to examine exactly what made this plant so incredibly promising and so deeply infuriating at the exact same time. The secret material is bamboo, and here is a fact that might catch you off guard. Bamboo is not actually a tree. It is a grass. It belongs to the exact same botanical family as the lawn in your front yard, just on a massively larger scale. On paper, bamboo seems completely perfect. It holds the title for the fastest growing plant on the earth. Certain species can shoot up by more than 3 feet in a single day. That means if you stared at it closely enough, you could practically watch it moving. While traditional timber needs a human lifetime to gain maximum structural integrity, bamboo gets there in a mere 6 to 9 years. Here is another fascinating detail that makes it so unique. Because it is a grass, chopping it down does not actually kill it. The complex root system survives safely below the soil, and a fresh stalk just shoots right back up. No replanting required, no bare deforested hillsides, and no waiting decades for the land to recover. Now, let us talk about its physical power, because this is where the facts start to sound unbelievable. When compared pound for pound, bamboo can withstand tension, and pulling forces significantly better than commercial steel. Its raw structural strength is roughly twice that of standard wood. Builders across Asia have recognized this reality for millennia. They crafted residences, river crossings, and massive scaffolding networks out of it long before modern blueprints existed. Even right now, laborers in major metropolitan areas scale towering bamboo grids to erect modern skyscrapers, putting their lives in the hands of this plant every single workday. So, if this material grows this quickly, holds this much weight, and helps the environment, why did the global engineering community ignore it for major projects for so long? To answer that, we have to look at its fatal flaw, the exact reason it was restricted to holding up the workers instead of holding up the actual building. In theory, a natural stalk of bamboo sounds amazing, but on an actual job site, it brings a ton of headaches. To begin with, the inside is completely hollow, making it incredibly difficult to join pieces securely. Next, it is naturally round, which is a nightmare for carpenters who rely on straight, rectangular planks. Finally, and this is the massive roadblock, its structural integrity is all over the place. One single shoot might be tough as nails, while a neighboring stalk from the exact same root system could be fragile and unpredictable. But wait, it gets worse. If you attempt to hammer a nail or drill a heavy bolt directly into it, the stalk usually cracks right in half. Plus, without heavy chemical treatment, it decays rapidly and becomes a buffet for hungry insects. Now, just think about how modern structures pass inspection. An official cannot just stroll onto a site and guess that a load-bearing column is probably fine. The industry demands materials that react the exact same way every single time they are tested, regardless of whether it is sub-zero winter, blistering summer, or 3 decades into the future. Raw, wild bamboo could never guarantee that level of reliability. Thanks to all these flaws, the construction sector slapped it with a dismissive label that lasted almost 100 years. They dubbed it the timber of the poor. It was seen as acceptable for rural shacks, but totally unfit for modern skylines. For decades, that was the final word. The architectural world entirely dismissed it as nothing more than a cheap garden accessory. But here is the brilliant twist. The innovation that shifted the entire landscape was not about discovering a superior species of the plant. It was about totally abandoning how we conceptualize it. And that revelation emerged from a totally unexpected direction. This is the defining question that turned the whole business inside out. What if, rather than handling this plant like standard timber and slicing it into clean boards, engineers treated it as a base ingredient, sort of like milling wheat into flour? That exact thought birthed an innovation known as bamboo scrimber, and the manufacturing method behind it is genuinely crazy to visualize. It begins with a fully grown stalk, but rather than sawing it neatly, massive machinery smashes it and rips it apart following its natural grain. In the business, they literally refer to this as fiberizing. The output does not resemble traditional lumber in the slightest. It looks like a messy, tangled heap of threads, almost resembling coarse hay. And here is the genius of this method. Every single flaw the plant possessed, the hollow core, the annoying tubular shape, the tendency to splinter, the wild inconsistency, completely vanishes. Why? Because the original tubular structure is gone. It has been totally reduced to elemental strands. From that point, technicians dehydrate those strands and submerge them in a specialized adhesive so it all bonds. Next, they align the strands perfectly parallel and compress them. We are not talking about a light pinch here. These layers are crushed under colossal hydraulic force while being blasted with heat, squeezing out basically every pocket of trapped air. What emerges from that heavy machinery is what makes seasoned architects drop their jaws. It becomes a hyper-dense slab that can literally be heavier than water, boasting a hardness that outshines premium oak or maple on the market right now. An unruly, erratic weed gets magically converted into a perfectly uniform, reliable building component. Astonishingly, this technique is incredibly efficient. Roughly 80% of the harvested stalk is utilized, even the warped, ugly sections that would typically end up in the trash. The performance statistics are genuinely mind-boggling. Premium-grade bamboo Scrimber reaches a compressive threshold exceeding 160 megapascals and a bending tolerance pushing past 300. Keep in mind, this is a rapidly spreading grass that bounces back in a decade, competing head-to-head with top-tier engineered lumber. Now here is a detail that might shock you. This isn't some fresh breakthrough cooked up in a startup yesterday. The original heavy-duty prototype was actually developed over in China way back in 1987 at Nanjing Forestry University. The underlying science has been stealthily advancing for almost 4 decades. What shifted recently wasn't the chemical formula. What shifted was the sheer audacity to deploy it on an industrial level. But making that dream real meant overcoming one massive, final obstacle that had absolutely zero to do with science. Creating a durable substance in a laboratory is incredible, but that alone will not revolutionize our world. Countless amazing concepts die in the experimental phase. The actual barrier that determines if a product goes global is quite dull, yet absolutely critical. The official building code. Construction regulations evolve at a snail's pace for a very good reason. The penalty for failing with a load-bearing material is not just financial ruin. It is about keeping structures from collapsing. A city planner cannot just drop a novel substance into a hospital or elementary school just because a single research paper claims it is tough. They require decades of rigorous trials, universally accepted benchmarks, and an undeniable trail of documentation that any safety official can easily verify. For the vast majority of bamboo's existence, that level of strict documentation was completely missing. And frankly, even right now, we are not fully there yet. When analysts recently surveyed manufacturers producing engineered bamboo globally, they discovered a glaring issue. Barely a third of those businesses provided transparent data regarding their material's true strength, and even fewer possessed standard green certifications. If you are a designer hoping to utilize this stuff in a massive undertaking, that missing data is a deal breaker. You simply cannot construct critical infrastructure based on statistics that manufacturers keep hidden. However, that divide is shrinking incredibly rapidly. Modified bamboo is currently undergoing the exact same rigorous global testing required for commercial timber. Scientific literature on this subject has skyrocketed. Close to 7,000 academic papers focusing on this material were released in the decade right before 2024. Every individual report provides one more chunk of concrete data that regulators absolutely require to greenlight a project. Gradually, this plant shed its reputation as a weird novelty and transformed into a certified material that professionals could comfortably stamp on legal blueprints. And once that trust was established, builders stopped restricting it to pretty flooring or outdoor decks. They began erecting structures that would have been completely illegal a mere decade ago. And their next projects are what truly make people stop and stare. For the longest time, the running gag regarding bamboo architecture was that it worked perfectly fine, provided you kept it to a single floor in a tropical zone, a lovely backyard gazebo, a pedestrian walkway, perhaps a quaint eco-lodge. Very charming, but hardly hardcore infrastructure. Then, the paradigm shifted. Over in China, teams successfully erected what currently stands as the globe's premier 7-story complex, constructed primarily out of advanced bamboo. We are not talking about a standard concrete block featuring some grassy aesthetic accents. This is a genuine high-rise where the load-bearing pillars, the floorboards, and the heavy joists are all manufactured from prefabricated, compressed grass. 7 complete levels constructed from a resource that experts mocked as a primitive material just a few decades back. And the innovation pushed past just housing. A prominent researcher, who divided his career between American and Chinese academic institutions, utilized this material to construct highway bridges capable of supporting passenger vehicles. One specific crossing over in Hunan province was pieced together using these factory-made grassy components by a tiny crew in roughly 7 days, requiring absolutely zero massive cranes. A roadway composed entirely of grass that allows heavy trucks to safely cross. This exact detail is what leaves veteran builders completely speechless. We have officially moved past the phase of quirky green science fairs. Engineered bamboo is actively stealing jobs that were exclusively reserved for poured concrete and structural steel. It is supporting immense loads in functional structures that average citizens occupy daily. Once an alternative proves it can handle that kind of stress, a broader thought emerges. The debate shifts from asking if it works to asking how massively we can scale this, because the nation driving this innovation is not viewing it as an academic hobby. They are treating it as a core pillar of their domestic strategy, and the magnitude of this blueprint is vastly larger than the public understands. Back in 2022, the Chinese government partnered with global plant organizations to kick off an aggressive campaign with a highly direct title: Swapping Out Plastic for Bamboo. Top-level officials endorsed this publicly, linking the program straight to their aggressive carbon reduction targets. The following year, they debuted a comprehensive 3-year strategy aimed at substituting highly polluting supplies, like steel, with this grassy alternative. Their roadmap involved establishing large-scale showcase regions to demonstrate that this supply chain could operate on a gargantuan level. That marks the divide between an interesting scientific paper and an undeniable industrial revolution. China commands about 20% of the planet's bamboo reserves, and they have constructed a seamless pipeline to harvest, refine, and press it into flawless structural beams. Based on their internal metrics, their natural grassy reserves pull down and trap roughly 300 million tons of airborne carbon annually just through normal photosynthesis. And serious capital is fueling this dream too. Their domestic bamboo sector aims to hit a valuation of 700 billion yuan by 2025, surging to a staggering 1 trillion by 2035. Whenever a superpower throws numbers that massive into the ring, international markets wake up and the race begins. When analysts plotted out the global manufacturers of this heavy-duty material, they realized about 2 out of every 3 were operating within China. But here is the fascinating twist. Fresh competitors are suddenly emerging across America, India, Indonesia, Singapore, and Vietnam. Even nations in South America, possessing their own towering native species, are realizing the massive export potential. The exact refinement process pioneered in Asia is slowly exporting itself globally, just like any legitimate manufacturing boom. The driving force behind this expansion isn't a sudden passion for saving trees. It boils down to cold, hard economics. If you manage a construction firm facing strict new carbon penalties and aggressive green mandates, a resource that regenerates in less than a decade and traps emissions inside your walls, rather than venting them into the sky, is more than a pleasant concept. It represents a massive financial edge, and no major player in the building sector can afford to brush off that kind of leverage indefinitely. But before we lose ourselves dreaming of a future metropolis constructed completely from tall grass, we need to address the very real drawbacks of this narrative. That incredibly dense, hyper-strong scrimber relies heavily on industrial glues to stay intact, frequently utilizing something known as phenolic resin. That specific adhesive is what grants the beam its waterproofing and insane durability. However, it completely strips away the label of being a pure, natural, organic product. It is officially a synthetic composite. We are still actively testing how it reacts in a massive fire, how it degrades over a half-century, and where exactly those chemicals end up when the structure is ultimately demolished. Furthermore, the logistics of production present a massive hurdle. Converting wild green stalks into load-bearing infrastructure demands massive facilities, shredding machinery, chemical vats, and giant hydraulic crushers. China spent decades assembling that exact manufacturing ecosystem. A developing nation surrounded by thick bamboo forests cannot just magically spawn these advanced factories overnight. The specific regions that desperately need affordable, rapidly renewing housing supplies are usually thousands of miles away from the heavy machinery required to process it. Bridging that divide isn't an engineering puzzle anymore. It is a massive hurdle of finance, labor education, and government regulation. And as we mentioned earlier, safety protocols advance slowly by design because human lives are on the line. Yet, none of these hurdles negate what the lab results have clearly demonstrated. They merely highlight the journey from our current capabilities to global adoption. And judging by the current momentum, that gap is shrinking way quicker than anyone in the heavy machinery world predicted. Which circles us right back to the central theme of this entire journey. Visionaries grabbed a weed that the architectural world relegated to making simple shacks. Instead of carving it like normal lumber, they completely pulverized it into base fibers, then fused it into a product that easily outmuscles the premium timber it aims to replace. It naturally regenerates in less than a decade without ever needing a new seed. It permanently traps greenhouse gases rather than burning them off. And at this very moment, it is safely supporting 7-story residential blocks and allowing commercial trucks to drive over rivers. Since the dawn of time, expanding our civilization meant slaughtering forests that required a human lifespan to mature. For the very first time in history, we possess a legitimate, heavy-duty alternative that fully regrows before a toddler finishes elementary school. That is profoundly revolutionary and genuinely exciting. If this deep dive altered your perspective on the furniture in your room or the architecture of your local city, please crush that like button. It is the best way to support our growth so we can keep making videos. Make sure to hit subscribe and ring the notification bell so you never miss out on future deep dives. Finally, drop a comment below if a simple grass that professionals mocked for a century became this powerful. What other massive solutions do you think we might be ignoring right under our noses?